Hi there, I want to introduce our next homework assignment, Anagram Solver. So let's start off by actually running the program and seeing what it does. So I have my anagram main and I have my own solution to Anagram Solver, which you're going to be writing. I'm going to use a dictionary file called dictionary.txt. And the phrase I want to scramble is Barack Obama. And what it's going to do is actually your program is going to be given the string Barack Obama, produce all of the anagrams or ways that you could break up Barack Obama into smaller dictionary words such that all of the letters are used. So one example of the anagram is abak arm boa. Another example is boa abak mar. There's a lot of them. You could also do, say, like my name, Hunter Schaefer, but actually my name has a ton of anagrams. So instead of just printing out all anagrams, let's print out anagrams that are up to length 2. And so there's only 2 of them. So you're writing the program to handle this. So what I want to do is walk through what choices your program has to be making. So we give you some smaller dictionaries to help you debug your program. So one example dictionary is dict0.txt. And we use the phrase George Bush. And we're going to say 0. And it's going to print out all of the words that we can combine in dictionary 0 to get George Bush. Now, the important thing about dictionary 0 is it's very small. This dictionary only has the words be, go, gush, and shrug. Only 4 words. So let's see what happens when you're given George Bush. So let's say you're asked to explore George Bush. What are the possible choices that you could include in your anagram? They're going to be either be, go, gush, or shrug. So this isn't the only choices. We're going to say is the first choice. So what is the first word you could pick to include in your anagram? And they could be any of the words in the dictionary. And so what we're going to say is, well, let's say, can we choose be from George Bush? And the answer is yes, because there is a B and 2 E's in George Bush. So we could say we're going to choose B and then explore whatever the remaining letters are. So in this case, it would be Gorg Bush if we took out the B, E, and E. And now we have a very similar task. We want to see, okay, now we've given Gorg Ush. How many other ways can I break that up in anagrams? So what are the choices for the next word to include in the anagrams? Well, it's either be, go, gush, or shrug. I can't actually take B out again because there's no B's. So I'll go on to the next possible choice, which is go. I can choose go, so I'm going to choose this one. Explore on the remaining characters, which is ush. And now I still have some letters remaining, so I need to figure out what other words I can include in my current anagram. And so the possible choices for the next word is going to be, go, gush, shrug. And now again, we can't use be, we can't use go because there's no O, and so we'll try gush. Can we take gush out of ush? And yes. So we're going to choose that. And what's remaining is we're going to explore with whatever's left, and after you take out gush, you're just left with R. So our program is actually going to be ignoring spaces and is going to be ignoring capital letters. So I did that over here when we eventually removed the G. We don't care about casing. Okay, so we have R left over, so let's see if we can use any more words to build up the anagram. The choices here are be, go, gush, and shrug again. Now, be, you can't take away from R. Go, you can't take away from R. Gush, you can't take away from R, and same with shrug. R can't be used for any of these words in our choices. So this is a dead end. So we're going to try all of these, but they're going to end up failing. And so since there's nothing else to explore, we're now backtrack and go back to where we were. So we were back here with gush, and we go into the next word and shrug. Now what's our current set of letters? It's currently ush. Why is that? Because at one point we chose gush, but then once we explored all the choices beneath that, we came back and unchose. So now we're left with ush. We say, hey, can we take shrug out of that? And the answer is yes. What's remaining? You're going to explore the empty string. There's nothing left. And at that point, once you've used up all the letters, you know you found a valid anagram for this word because you've built it up out of smaller words such that there are no letters left over. And so at this point, once we know we're done, we're going to print the words we used so far. And those words were be, go, shrug. And so you notice with our program, the first thing it printed out when we ran George Bush was be, go, and then shrug. And then we'll go on for the rest of the trace and do the rest of it, but this is just the first thing it printed out. So you'll be doing this choose, explore, unchoose pattern. So this will be helpful because in lecture on Friday, or on Wednesday, we wrote the 8 Queens program. And using the 8 Queens program, we then generated what would this trace of decisions look like. So we said, okay, given this code, what are all the decisions I'm making? We traced out what the program was doing. And so if you're stuck on this assignment, you don't know where to go, you might want to use this as a chance to do the opposite. If I give you a trace of the program, can you come up with the code that produced that trace? So I show you all the choices you have to be making in this trace, and now it's your job to come up with the code. And also, this assignment can be kind of tricky because there's a lot of output, so if you get a bug, it might be hard to figure out where the bug is. This example, using the small dictionary in George Bush, is a great way to debug that. If you don't make the exact same set of choices I do, then you probably have a bug in your program because we want you to be making the exact same order of choices. Okay, so for this assignment, we are going to be doing recursive backtracking, and there's also this notion of keeping track of all these counts of letters. And I think if you had to write all of the code to figure out how to take away counts of letters within the code for backtracking, that would be very complicated. It'd be really nice if we could abstract away the details of counting characters, kind of like for the 8 Queens problem, we abstracted away the board, so we didn't have to worry about the details of the board. So it'd be really nice if we had a class that kept track of the counts of letters and strings. And that should sound a little bit familiar because that was your first homework assignment. So for your first homework assignment, you wrote letter inventory, which is a class that does exactly that. So you are going to be a client of letter inventory for this assignment. So let's just remind ourselves what letter inventories do. So I can say I'm going to make a letter inventory I1 equal to a new letter inventory, and I can give it a string, like let's say George Bush. And it does all the work for ignoring case and removing spaces, which is really nice. And I could do, say, system.out.println I1, and this should print out all the letters in George Bush. Perfect. Okay, well, let's make another letter inventory. I2 equals new letter inventory with the word B. Now, remember, there is something we made you implement for letter inventory that will be very helpful here. How do you take out the characters from George Bush that are in the word B? And that method we implemented was subtract. So you could say, hey, I want to make a letter inventory, I3, equal I1.subtract I2. And then if I print out I3, what we'll see is that it will be all the same letters as, there's a typo, it should be all the same letters as I1, except missing the ones from the word B. That's exactly what we get. One last useful thing to remember about letter inventories, what happens if I subtracted B again? So if I said letter inventory I4 equals I3.subtract I1, so what if I took these leftover letters and subtracted the word B from it? Let's see what we get. And I can't spell again, inventory. I'm a very bad speller. We get null. So remember, you implemented the code so that if you couldn't remove characters, then you return null. So this will be useful things to remember. And so the spec walks through all the kind of stuff you have to do regarding letter inventories and regarding how to make this program a little bit more efficient. So the spec will define what efficiencies you need to worry about. But for your first attempt at the assignment, you might not have to worry about them, especially with the small dictionary. You don't have to worry about all of these possible choices because there aren't that many. So really focus on the core algorithm before you actually go and do those optimizations that we described in the spec. Last thing I want to point out is this trace I built up with us during this video is super useful, and so it's actually posted on the homework page. Posted as under sample trace using dict 0 b go gush shrug, and it shows all of the choices is made in this program. And it's basically the same thing, except instead of showing the strings, it's showing the letter inventory counts. And so this trace is really useful if you're trying to figure out what's going on. Some people prefer a picture of a tree, and so we also include this picture of the tree, the decision tree for this exact same thing. Both the trace and the tree are exactly the same. They're just different ways of looking at it. Okay, best of luck on the homework. Bye.